Hello, everybody, and welcome to the CIRCit webinar series. Is remanufacturing better than recycling? Or should we maybe go for reuse? Deciding on what is the best circular economy strategy is not always as straightforward as it sounds. In the webinar today, we will provide you a number of insights into how to close the loop for a circular economy with an overview of a number of different circular economy strategies and also very detailed guidelines on how to decide about the best strategy to implement for a given context. Closing the loop for a circular economy has been one of the focal areas of the CIRCit project, which aim to support manufacturing companies in the transition from a linear to a circular economy. Over the last 3.5 years, we have involved a number of different companies in the co-development, evaluation, and implementation of a number of different tools and approaches that can help this transition. A little bit about me. My name is Daniela Pigoso. I'm associate professor at the Technical University of Denmark, DTU, and one of my main research topics is on circular economy. I've been one of the co-leads of the CIRCit project together with Professor Tim McAloon, and today I'm planning a more a facilitator role. Our webinar today will take about half an hour, and our main goal is to provide you with an overview of the existing recirculation strategies on the basis of a scanner that we developed in the CIRCit project, and then provide you a number of tools and guidelines to actually help you to decide what is the most relevant strategy for a given context, and also how to further evaluate that towards the implementation. And for that, I'd like to invite Jutta Hildebrand. She's a researcher from RISE, the Research Institutes of Sweden, and has been one of the key partners in the CIRCit project over the last 3.5 years. Jutta, many thanks for being here today. We are all very much looking forward to hearing more on how to close the loop on a circular economy context. Thank you.
Thank you, Daniela. I'm going to share my screen now and right to the topic today about how to close the loop and how to close the loop for existing products. This is the workbook 5. You can find it when you go to the website and click on workbooks, and then you will find all of them. Now I'm probably shouldn't do this. I did it anyway. It's right down here in the middle, closing the loop for a circular economy. And I'm going to talk you through the workbook in a bit more detail, and also would like to share a bit how we came to this workbook and how we ended up with the strategies and the project that we did. I get some feedback that something is not working, but that's probably just me. So like all CIRCit focus areas, we worked with companies, together with companies, and what we found was that companies are not fully aware of the options that they have in the recirculation parts of the circular economy. So this workbook has an introduction and gives you some insights into the CIRCit project in general, and will also lead you to the circular strategies scanner, where you can find all of the circular strategies, but it will then focus foremost on the recirculation strategies for parts and products and on the recirculation strategies for materials. And this is for existing products might be a starting point, but also future products that are designed to be more circular can still be recirculated or should be recirculated. So what is an existing product and why does it become an issue and an item that you need to treat? There are different and many different reasons. One of them is that the owners still actually simply don't see a use for an existing product anymore. That's very subjective, but it can be that they find it outdated or it's no longer functioning fully well for their purpose. And in this case, you have a product that is still on an objective level fully functional, but is no longer desired by the user. or it can be that they have outgrown it, or also that it's not fully functional on a temporary basis, so it needs some attention, or that it's completely broken, or that it's difficult to operate and even dangerous to operate because it contains some materials that we don't really want anymore in the market. So these are different reasons why a project ends up as an issue that has to be treated and that should be recirculated. And here the circular economy actually has very new aspects compared to eco-design and existing approaches to limit the resource use and increase the resource efficiency, that you want to take as much of the value of this in this product to a new use, or if it's not, this is not possible, to a new life, and to transfer at least the material to another use phase. And these are the two groups that we have here. The blue group, where we thought about a recirculation of products and parts, and the gray part, the recirculation of materials. And it's in both of these blocks, you have a sort of a hierarchy, and that is we try with that to appreciate that not all upgrade or not all recirculation strategies for products take all the value with them in the next life or in the next use phase, and I will go through the in total 9 strategies and come back to that a bit more. So what we found is that companies are not fully aware of the options that they have in recirculation, and also do not know all the differences between those different 9 strategies that we have here. So we have decided to add a bit of background information. And here you can see that we now fully focus on the blue and the gray part. We have the 9 recirculation strategies for parts and products and for materials. So it's 6 for parts and products and 3 for materials. And they are explained in a bit more detail here. What is upgrade about? It's about update, modernize, renew, retrofit, and rebuild. This is clearly a strategy for a product that in principle would still work, but is no longer considered to be useful by the current owner. So there you work with the existing products, keep the structure of the existing product, and add or replace parts to make it more attractive and make it attractive again. Similar is also with repair and maintenance, where you have to add materials or replace materials that are broken to prolong the life length of an existing products. Reuse actually means that a completely functional product can be sold to a new user with the same product, and maybe the new user would still like to use that, and the previous owner did not like it anymore for whatever reason. That's not an area that we challenge here. Then come strategies where there's a bit more intervention, the refurbishment, which is quite interesting for electronic products, as you can see here. So we have an example of a Swedish company who does that for computers and notebooks and electronic equipment. There are more examples than that available. And then we have remanufacture, which is a more in-depth and a more thorough and a more as you can see up here, a more detailed process to create the value and rebuild and restore the value to as new or even better performance. And now we have also one recirculation of product, where we understand that this will not take the whole value and all functionalities of a product to a new life cycle. And you can find that sometimes when you have the facade of a building, or the exterior and the general structure of a building can be used instead of an office building for private home or the same, and then you take out some of the interior, but you still keep the shell. And this is, of course, not the same level of transferring value to a new use cycle, but compared to upgrading or reuse, but it still takes a lot of the materials and value with it. And those were the 6 strategies that are linked to recirculation of products and parts. And then we have the recirculation of materials. And this area is not necessarily linked to products. So here you can see that some of the strategies work quite as well also for production rests and other types of rests from that come out of a company. But here you destroy the shape and destroy the structure of the product, and you're willing fully do that because there's no demand for this type of product anymore. It's already too much broken to guarantee a safe use in another use cycle. But it contains a lot of valuable materials such as glass, or in this type of glass, and a very valuable polymer that can be used to reduce noise. So this is can be applied for windscreens from cars, where you can separate the glass and the polymer and bring them back to the market and bring them back to the economy, which is quite valuable. When you can't use all the materials that have been part of the existing product, or when you find that the effort for such a high level recycling is not feasible or is not possible, then you can still find some cascading use in some cases. For instance, when you have mixed plastic waste, they can be molten down together, and then you can no longer produce these very thin layers of plastic, but it's useful to for instance, to create park benches and this type of application. So this is still a possibility. And then you have the recovery, where you actually only still take one property, and in this case the calorific value of a plastic or nutrients, and take them to the next level. So here you have all the 9 strategies, and I'm going to go a bit further and come back to that soon. So you have to find out a bit about your product and find out whether there's a demand for this type of product on the market still, and then you can decide what to do with it and which of the strategies might be the most suitable for you. So you start with the product that is to be evaluated and go then, is there a demand for the product on the market? And when you see no, then you will clearly end up with not with reuse, but you can still find recycle, cascade, and recover as the possibilities. And when you see that there's a demand for the product, then you further decide in the current state or with improved functionality after it's fixed. So very simple and clear question that can lead you to a strategy, and maybe some strategies that might all be helpful. So now I'm zooming out again and go back to the evaluation part. We assume now that you have come to the conclusion that this would be a good idea to go for example, remanufacturing, and then you have to analyze, or you should analyze the feasibility of this approach. That means, is there a technical process available that's offered by some, at least, that is supposed to help you with this, and also the viability, how much will that cost, and what are the resources that are needed to make this happen. These are linked to the technical process, and there are also organizational questions and legal and compliance questions around that. So, for instance, that's something that we notice quite often. Shipping used products or waste, and then especially waste over a border, is not something that is accepted in all countries. So you have to make sure that what you are planning here is actually also legal. And Here you can also see that you can think about an organization and network. So who else has to be involved? Do we do this alone, or is this in particular for a small and medium-sized enterprise something where you need a network? And to do this further, there are also, now I have to go back to the website. There are some tools that you can find immediately on the website. Hope I can find that immediately. This is, I have trained this, but you never know. Where are my tools? Tools, sorry. Here we are. So here you have the scanner, and here you can find the circular economy market and product decision tree, where you can see that decision tree that I showed you just. And there are also some background data. And one of the important parts that the circular economy contributes with is that you consider the recirculation also of critical raw materials for which there's a supply risk and for which there is also a high economic value that's needed for very, very key industries, and so you can find some information on that. When you want to go to the market and product decision tree, there's also an online version of that I encourage you to try out. And here you can see also the procedure for the evaluation of the feasibility and viability. So this is how we treated this, and it's appreciating the fact that companies actually need more information and need neutral and honest information on what are the options and what can be done. And that's how we ended up treating this. And this is what I wanted to talk you through today. And now I'm going to stop sharing, if I manage that. And
thank you very much for a nice presentation, Jutta. We do have questions for you, so let's start with the first one. Quite in the beginning of the presentation, at the time that you were showing all these strategies, you mentioned that there is a hierarchy. Does it mean that remanufacturing is always better than recycling?
Thank you. That's a good question, a really good question. And the question is, in many of the environmental science, we say that depends. So if remanufacturing is a possible option, depending on the demand for the product, and you have found out that there is a demand for this product, and that you can bring it back to the market, and it will have a useful second life or second use, then remanufacturing is beneficial or better than recycling, because then you keep the structure and you bring back the product and the materials and the structure both. So you bring back more value to the market or to the economy. Whereas in recycling, you destroy the structure and you have to have efficiency losses. There is no recycling strategies will bring you back 100% of the material. But so if the product still works and if it has still full functionality, go for remanufacturing. If you know that the product contains, for instance, hazardous materials, you have flame retardants, or you have other chemicals that are no longer accepted due to legislation, for instance, in your breach, then recycling can be an option to take away what you don't want on the market anymore, and to bring back the bulk material. We need also to bring to speed up and have more sophisticated recycling methods to do this. So it depends.
Yeah, that's the answer that every life cycle assessment expert loves.
Sorry about that.
We actually have a question about life cycle assessment here, and they're asking whether doing LCAs can help in actually taking this decision if it's better to remanufacture or to recycle.
I wish that I could say yes in this case. I think I'm a life cycle assessment expert, and I really like to use the method where I can see that it benefits. I'm not sure here because I think that the data on recycled materials and recycling process are not there yet. But I wouldn't, if we build up better databases and if we build up better information on reuse and on recycling, then sure it will help. But at the moment it can be a bit tricky. So when you do an LCA, be very skeptical and be very thorough reviewing your input data.
Great, thanks for that, Jutta. The next question that we have has to do with what is required to be in place to actually implement those strategies. The person mentioned, for example, infrastructure, but are there other elements that need to be in place?
Yeah, that's another excellent question. And I think I wanted to mention also that this workbook is a part of a series of 6. So the implementation will certainly take make demands also that you think about the business models. And you probably can take also learnings from this analysis of existing products and think about how to design new models or new products and the next generation of your products. So infrastructure is an important part. Networks that I tried to mention, also the organization and the network part is very relevant. Maybe you don't have to do this yourself, or you have to find a good partner who can help you. And yeah, that's that.
Another perspective that we have in the questions here has to do with the sector-specific strategies. So how does those strategies change sector by sector? And could that also be a way of selecting the most appropriate ones?
Definitely. So this what I showed in the demand decision tree is a very high level of information, and it's mostly for manufacturing industry that handles metals and other types of long living materials. I can give you also the tip that you can look into the online version of the decision tree, and there you can select your sector, industry sector, and have a look and explore how this might change the results. So that could be also an idea.
Perfect. And the next question that we have here is about companies taking back products from another companies. So they did not necessarily develop those products, but they might see a potential of implementing circular economy. What are the main considerations that those companies need to make before deciding to take or not take those products back?
Right. That depends a bit on which type of strategy they adopt. So if you have there is a company in Finland that takes back only iPhones and repairs them and sells them then with a 12-month warranty, and it's not connected to the original manufacturer in this case. So there are examples that this is happening, but it's also clear that then the third party does not have access to the original bills of materials and has to guess in some cases what this is. So there is a bit of a limitation, and the high level remanufacturing is probably done at least in cooperation of, can be a third party company, a small company, but at least in cooperation with the original equipment manufacturers. So the level of information is obviously higher with the original manufacturer. But then on the other hand, it's also that you need access that only the users have. So for instance, the users know when they did some maintenance and what they did during the operation, and that's knowledge that the manufacturer not always has access to. So it's a bit finding the right person and finding the right contributor to create enough knowledge to evaluate that properly, and is can be a tricky thing.
Yeah, you just mentioned about the original manufacturers. Could this decision tree also be used somehow to guide new design projects should enhance how a product is designed?
In this case, I would refer to the workbook 3 mainly, because that's the design for circular products. But here I think that here you can learn for the recirculation part of existing products, and you might find that some strategies simply do not work because, for instance, disassembly was not considered properly in the original design, and this can be a learning that can be taken to the next design. And so I would recommend to do in that case do a proper investigation, both using both the workbook 5 and the workbook 3, and see how you end up with that.
Perfect. And then we have another question connected to the recirculation strategies, and more specifically to the gray area in terms of recycling. So the question here, as part of the decision tree, do we need to have a top layer to distinguish between upcycling, recycling, and downcycling of materials?
Not according to me, but I think that you will probably can adapt that to consider both, because upcycling and downcycling are very subjective terms, and sometimes people will say that, for instance, when you have PET bottles from Coca-Cola or from other beverages as an input, you can produce very nice textiles for garments and especially workout outfits made from polyester based on that. And I don't know if you would call that upcycling, recycling, or downcycling, because basically it's a very high value product. But on the other hand, you cannot go back to the original product. So I think you need to be very clear what you mean by up and downcycling. How far is it reversible what you do in the next life? Can you go back to the original state, or do you do something that is a one-way road? And think about the demand for this product that you're going to use.
Perfect. Then we have a question that tries to bring more the economic elements to the discussion. And we know that customers, they often expect a low cost of products. But what can we do in case the implementation of a given recirculation strategy, such as recycling, leads actually to more costly products? And then he provides an example here, for example, the recycled concrete block in the construction industry.
The recycling, oh, sorry, I didn't get this little part.
The recycled concrete block from the construction industry.
Yeah. The construction industry is actually a very interesting industry for the circular economy, because we have so large volumes of materials that are not very expensive, and handling them is maybe more expensive. So just sorting them on a construction site in the right way takes much time and takes much manpower. So you probably end up simply putting them together as you shouldn't do. So there are attempts to find a better balance between material costs and work costs, because that is at the moment what makes the recycling or also other re-strategies more expensive, that you need more manual labor. It happens on a smaller scale compared to this very large primary production, and the economy of scales then really gives you some problems. Yeah, I cannot really answer that, but I find it a very interesting question, and I think I will get the questions also, so I can try to think about that a bit more. I'm not an economist, by the way, but yeah, I can try to think about that a bit more.
Perfect. And we only have time for the final question. And the question here is, how does your work relate to the Ellen MacArthur Foundation similar research, and what are the key differences there?
Mm, right. What I can say about what we tried in the CIRCit project was that we tried to be a bit more clear about the differences between recirculation strategies. And I think that the Ellen MacArthur Foundation often does not prescribe any a specific way or a specific approach. It's very broad, and it's not, don't give any recommendation. It just lists a lot of options. So what we did was try to find out what are can we summarize, and can we in a nutshell describe what are advantages and also what are requirements to implement a recirculation strategy. So that's what we were aiming for.
Thank you very much.
You decide if we succeeded.
We don't have more time for questions. Thanks everybody as well for sending the questions and for the nice discussion. Just before saying goodbye, I just have two invitations to make to you. The first one is for the physical workshop we'll be having here in Copenhagen in September. We are planning also to have hubs in all the 5 different Nordic countries, so you can also attend physically. And the main goal of this workshop will be to give you the chance to have a hands-on experience on how to apply all of the tools and decision trees and models that we developed in the CIRCit project. If you have the interest to join, I've just added the link in the chat box. So just get online and pre-register so we can send you more information about that. And finally, I also want to invite you for our final webinar in this series that will be tomorrow. The main goal of the webinar tomorrow will be to look into how to collaborate and to network for a circular economy. We all know that it's not really possible for one single company to make this transition alone. So tomorrow we are going to provide you with a step-by-step approach about how to identify the right partners to engage in this journey, and then also how to establish partnerships with them. I will be the one providing the webinar, but the work has actually been done by Professor Fenna Blomsma. She's now at the University of Hamburg in Germany, and I'll do my best to share the results with you tomorrow. Okay, so that was all for today. I hope that you are more clever now about how to close the loop for a circular economy. And I see you tomorrow. Thank you. Bye-bye.